Okay. Hailstone that fell from the cloud struck the top of a tower at the peak that was broken into two pieces. One piece X was thrown up 0.5 meters from the top of the tower. From that point, starting from rest, moved down vertically under gravity and struck the foot of the tower. It moves up and struck the foot of the tower. Time taken by X to reach the foot of the tower was 2 seconds. It means the total time taken for the motion 2 seconds means from here to here it has taken, let's take t1 time, t1 second, and then from here to here it has taken t2 second. Therefore the total time t1 plus t2 is equal to 2 seconds. That is what they have said. Explore calculate height of the tower using a VTA graph linked to the motion of X. Draw the VTA graph for motion of X from rest. How are you going to draw? What they have asked? They have asked velocity, that is in meters per second, and time graph in second. Actually, what is happening here? I will take only this motion. Here, this particle X is at rest. Rest means velocity is equal to 0. It's going to come here and then it is going to knock here. It will knock here with a velocity. Now, this is practical. I am going to take a ball. It is going to here. I am going to drop it. It is going to hit the floor. Likewise, here at rest when velocity is equal to 0, and then it's going to strike the floor with a velocity. It's going to hit the floor with the velocity. Okay, so when this is moving, you know that there will be acceleration. In the question also they have said after it has come to rest, this particle X is moving under gravity, under gravitational acceleration. That is, you know, gravity, there is an acceleration acting on it, that is 10 meters per second. Actually the gravitational acceleration is here. Gravitational acceleration is taken here. T1 plus T2 is equal to 2 seconds. Here we have the VT graph. So here at velocity is equal to 0. After some time it will have a velocity v1. After some time it will have velocity v2, and then let's take the velocity that is hitting on the surface is v3. So because it has an acceleration, now let's take, now this is a vertical motion, is bit difficult to understand. Like we'll take the horizontal motion. Here I have a box here, its velocity is 0. I'm going to accelerate it. What do you mean by accelerating? It means I'm giving a force. If I give a force, there will be an acceleration. If there is an acceleration, there will be change in velocity. If there is change in, because there is an acceleration, change in velocity will be positive. If it is 0, for example, let's take, because there is an acceleration, this velocity will be 5 meters per second, and then it's going to be 10 meters per second. Likewise, if the acceleration is constant, that is, now let's take, I am given acceleration of 5 meters per second, 5 meters per second. 5 meters per second minus 2. I am giving this acceleration. I am giving constant acceleration. What do you mean by constant acceleration? In a given time, in a unit time, now let's take for 1 second, this is 1 second, this is another 1 second. Okay, 5 meters per second minus 2 means, you know that the acceleration is equal to change in velocity divided by time, right? Change in velocity divided by time. So my time is here 1 second, acceleration is 5, so change in velocity change in velocity is 5 into 1, that is 5 meters per second. 5 meters per second. Initially it's 0, change in velocity is 5, so it's 5, and then it's the same acceleration, that is 5 meters per second, so it's going to increase up to 5 meters per second. It means each and every second velocity is going to increase by 5 meters per second. For 1 second, going to increase by 5 seconds, another 1 second by 5 meters per second, another 1 second by 5 meters per second. The motion is going to be on that way. This is what is happening in the vertical motion. Because it has a constant acceleration of 10 meters per second in every 1 second. For 1 second, this velocity will increase by 10 meters per second. Velocity will increase by 10 for 1 second. Now let's take from here to here. It's 1 second. 1 second. Velocity will increase by 10. It's 0, so it's going to be 10 meters per second. For another 1 second, velocity is v2, so it's going to be 20 meters per second. v3, it's going to be 30 meters per second. Okay, so this is what is happening. Now let's take like this: 1, 2, 3, 1, 2, 3. 1 second. From here to here 1 second. From here to here 1 second means t is equal to 2 seconds. T is equal to 3 seconds. Okay. So 1 second, its velocity has become 10. From here to here 1 second. Here to here 1 second. Here to here 1 second. If here to here 1 second, here to here 1 second means from here to here it's 2 seconds. Now let's take this as point A, point B, point C. From point A to point B, it has moved 1 second. Point B to point C, 1 second. And then point C to, until touch the surface of the flow, another 1 second. So each and every second velocity is going to increase by 10. So here A to B 1 second, B to C 1 second, then from A to C 2 seconds, right? Okay. So in 1 second its velocity increased by 10.